In this lesson, we're talking about radical functions. Radical functions are functions that contain some sort of root. In these two examples, the functions contain a square root, but radical functions can also include cubed roots, fourth roots, and so on. We're going to talk about the domain, horizontal intercept, and vertical intercept of these radical functions. So the key thing when determining the domain, what is inside the square root must always be greater than or equal to 0. So we are going to set what is inside the square root greater than or equal to 0. And now we will solve this inequality. I'll add 4 to both sides. Divide both sides by 4. So our domain, x must be less than or equal to 3 in order to get real numbers in our range. So I'm going to write that in interval notation. The domain can go as low as -infinity, but x cannot exceed 3. But it can include 3 because we can take the square root of 0. The horizontal intercept, we set y equal to 0. So I'm going to do my horizontal intercept in green. So our f of x, or our y, is going to be 0. We're setting the function equal to 0. I can square both sides, add 4x to both sides, and divide both sides by 4. Our horizontal intercept is going to be at 3, 0. So you can see there's a connection between the domain and the horizontal intercept. The endpoint to your domain is going to be the x value of your horizontal intercept. Now let's find our vertical intercept. I'll use red. For our vertical intercept, we are going to set x equal to 0. So y is equal to the square root of 12 minus 4 times 0. Y equals the square root of 12, which we can simplify. We can factor out a perfect root of 4 and evaluate that root. Y is equal to 2 times the square root of 3. So our vertical intercept is going to be at 0, 2 times the square root of 3. And now we want to draw this function as a graph. So I'll go ahead and draw an x and a y axis. We know the domain goes from -infinity to 3, and our horizontal intercept is at 3. I'll draw it in blue. So this is our horizontal intercept. And our vertical intercept is 2 times the square root of 3, which I'll plot right here. And then I will go ahead and draw. It's essentially half of a parabola. Make it a little nicer. There we go. And that is what the graph approximately looks like. You can double check in Desmos and make sure the graph looks the way you want it to. Our next function, we are going to follow the same processes. What is inside the square root must be greater than or equal to 0. So I'm setting everything inside the square root to be greater than or equal to 0. I'll add 5 to both sides, and I get x is greater than or equal to 2.5. So for this domain, we are going to have a hard bracket on 2.5, and it goes all the way up to infinity with a soft bracket. Now that we know that the domain and horizontal intercept are connected, we know that the horizontal intercept is going to be at 2.5, 0. The vertical intercept, however, we will have to calculate ourselves. So I'll go ahead and do that in red again. So we're figuring out what y is when x is equal to 0. We get y equal to the square root of a -5. So that's going to be an imaginary number. If you get an imaginary number as your vertical intercept actually does not exist. We only want numbers in the real number system. So we can go ahead and graph this. I'll put our horizontal intercept in and label it. And our half a parabola is going to go in this direction this time. Again, feel free to check in Desmos if you want a more accurate graph.